Why is nothing is working? Screenshot. A piecewise function is just like it sounds. You have pieces of a function that are different shapes, okay? So a piecewise function gives you these constraints. These constraints here are when x is less than -2, my answer is just going to be -2. If x is between -2 and 1, then it's going to, I'm going to plug it into there. If x is greater than 1, then my answer is just going to be 1, okay? Like if we'll talk about graphing these in just a second, but the graph of this looks something like, I'm drawing a rough graph here, so this isn't going to be perfect. Greater than 1. Actually, this goes down here. The graph of this is different, and these are more real-life graphs because, you know, if you're talking about like profit, your profit's not going to have like one shape to it. It's going to have multiple shapes. So, you know, you may be constantly in the negative, and then you may have a little up and a little down, and then you may be constantly in the positive, okay? So these are more like real-life type shapes because there is a lot of different functions here that's happening. So you have these different spots, and what you're going to do is there's a constraint. So this one is actually pretty easy, this topic, but you got to be careful. So h of -2. This says x equals -2. So when x is -2, this is -2 is less than or equal to, I'm under this one right here. X is -2 because it's -2 is less than or equal to x. So I am under this constraint when x equals -2, okay? So I am only going to plug it in to that middle one right there. So -2 plus 1 would be -1. And then you square it, so it'd be +1, and then my answer ends up being -1, okay? So you have to pick which one it fits under. H equals 0. This is x equals 0. That, again, is going to fit under this one, okay? So I'm going to put it into this one. When x is between -2 and 1, I use that one. So -0 plus 1 squared, 1 squared, and then the negative. So that would be -1 as well, okay? And then the last one, when h is 2, on this one, we're saying x equals 2. So x equals 2 on when, right here, x is greater than 1, I use that one. And when x is greater than 1, my answer is just 1. Okay? So you have to figure out which one x fits under and only plug it into that one. Oh, no, wait, I wanted to got a picture on that one. So on this step 1, actually, this is called the step function. Because the graph looks like a step. We may do that in a minute. But as you go through each of these, okay, this is x equals -0.5. So when I'm going through here and figuring out which one that is, this one is less than, this one is less than or equal to, right? So that would be where x equals -0.5. So my answer is just -1. This one, 0.3. X equals 0.3. That would be this one right here. So my answer is 0. This one is 0.5. So that looks like this right here, right? X equals 0.5. So my answer is 1. Okay. Your answer, you got to figure out which one to plug it into based on those constraints. And then you get your answer there. All right, I skipped the domain one. Or I didn't skip it, but it's next. All right, so the domain of a graph and the range of a piecewise graph. Remember, might have been a bit since we've done domain and range. but the domain is your x's. It's how far left to right your graph goes. All right. So left here would be -4. It's a parentheses because it's open. And then 1, again, a parentheses because it's open. And then here it would be, the other part of the graph would be 2, and it stops at 4. And then you do a union symbol to say or. So x could be any number between -4 and 1, and x could be any number between 2 and 4. And it can't equal any of them because they're all open circles. So you use parentheses on all of them. The range is how far down to up. So the bottom of this graph right here is at -5. Again, it's a parentheses because it's an open circle. And the top of this graph is at 3. There's only 1 here because when I look left to right, there's a gap, right? There's a gap right there. But when I look up and down, there is no gap because they overlap, okay? So I do not have to write the or symbol right there. I don't have to do 1 for each one because there is part of the graph somewhere all the way between -5 and 3. Let's see if we can do another one of those. That's pretty similar. See that one? That one looks weird. All right, so the domain of this one, the furthest point left would be 2. And then, well, it does equal 4, right? But this one's also at 4. So if this one ends at 4 and this one starts at 4, then I can go all the way to here, which is 5. There is no gap in the graph. So it goes to 5 with a bracket. It's okay that this one is closed and this one is open because I still have an answer. If x is 4, y is 1, right? So I have an answer there. My range, the bottom of this graph is at -4. The top of this one is at -2 with a bracket. But then there is a jump, a space. So the or 0 to 1 with a bracket. Okay. So there is a gap here. So I am going to use, when I'm looking up and down, there is a gap right here. Okay. There is no gap when I go left to right because they start right where the other one picks off. So you only use the or when there is a gap. All right, the graphing part of this is the hard part. It's just kind of hard to do on the computer, to tell you the truth. So the first one is it starts out with a step function. What this is telling you is these are your y values, okay? This is always like y equals whatever number is right here. So always think like y equals. So if I have y equals -2, what kind of line is that? Anybody? It's a horizontal line, right? So y equals 2. So this says, what this is saying is anytime x is between -2 and 1, my graph is going to be a horizontal line at y equals -2. Okay? Okay, so we'll make this one blue right here. So I am going to go to x equals -2. It is less than or equal to, so I'm going to put a solid line, and it is open at -1. And it is a horizontal line in between. Okay? The next one starts at -1, and it is a closed circle, and then an open circle at 0, and is a horizontal line at -1. The next one's at 0, or is 0, at 0 to 1. You can kind of see how they call this the step or the stair function. So the last one here is at 1. I'm sorry, it is 1, so it's at 1 to 2. Okay. So once you figure out the pattern on those step functions, this one's the easier one. But you have that pattern right there that goes. Just be careful with your closed circle and your open circle. You do that because the closed is when it's less than or equal to. The open is when it's just less than or greater than. I don't think those first ones, I think y'all see that pattern pretty quick and get those. So the hard one must be the next one. Yeah, those are all going to be... Oh, if that's equal, let's do that one real quick. Not really much different, but... Oh, these have less than. Okay. So on the top one right here, again, think about like y equals. So y equals -1 is going to be a horizontal line. When x is less than -1. So less than -1, my graph is going to be -1. So less than would be an open circle, and it's less than, so it's going to go forever this way. Okay. On the next one, it's x equals -1 and then -2. When it's equal, it's actually just a point. It's just a point that you're dealing with. So it's at -1, -2 would be here. And then my next one is when x is greater than -1, I'm at 1. I'm at 1, open circle, and it's greater than, so it goes forever to the right. Okay. So these are a little tricky. You just got to take each one piece by piece. I think kind of doing the next topic kind of shows you how to do it better. Oh, we got to continue this. Okay, so this is, remember I said that the left side is like y equals. This is like y equals. So my first one right here, this is actually like y equals mx plus b. This is where these get tricky. So my slope is 4 and my y-intercept is 3. So I'm just going to draw that graph real quick. So if I was drawing that graph, I'd start at 3. I'd go up 4 to the right 1. This graph looks like this right here. Okay? But I only want to look at this graph when it is less than or equal to -2. So -2 is right here. So I only care about this graph when it is -2 or less. So I would actually go in and I would erase, it's a really big eraser, everything to -2. And then it's less than or equal to, so I put a point right there. That is the way you have to think about these, and it's not the easiest. Especially if I start at my y-intercept, which is 3, I'd go down 4 to the right 1. I'm sorry. The opposite of going up 4 to the right 1 is down 4 to the left 1. Down 4 to the left 1. Man, I drew that graph really bad. So if I was doing this on the computer and I had to go, I'd plot my y-intercept, and then I would go with my I know my slope is +4. So it's up 4 to the right 1. The opposite of that is down 4 to the left 1. Down 4 to the left 1. Now I'm at -2. That's what I want to get to, is where x equals -2. And then I say it's less than or equal to, so I do a closed circle, and then I draw my graph. It's forever down from there. Okay? So I only want that part of the graph that is less than or equal to -2. On the next one, again, this is like y equals x minus 2. So my slope is 1 and my y-intercept is -2. So I start at -2. And I want to, again, work to -2. So if I'm up 1 to the right 1 is what I'm supposed to do. The opposite of that is down 1 to the left 1, down 1 to the left 1. This is going to be an open circle right here. And I want when it's greater than or -2. So if my whole line looks like this, I only want the part where it's greater than or -2. I only want that side. Again, I don't care about this side because I only want when it's greater than -2. So I only want that side right there. Does that make a little bit of sense? This is why it's called piecewise functions, because you want that piece of the function under the constraints of when it's less than or equal to -2 or not. Continuous, the word continuous right here means I think about trace with pencil and never pick it up. Okay, so this one's going to be no, because as I trace this one, I would have to pick it up and jump to my red one. Okay. That's kind of the easiest way to see if it's the continuous or not. Why is it not letting me scroll down? I did want to see if it let me do one more real quick. I know I'm out of time, but let's see what another one is real quick. That one's very similar. Okay, they all do look very, very similar to that. If we need to do another one on Wednesday, we got 2 modules done today. So